All right. Today's video, we're going to start chapter 7, and chapter 7 is on sequences and series. A sequence is an ordered list of numbers. Okay, a sequence is an ordered list of numbers. When we get to a series, is the same thing as a sequence, except for those numbers are now added up instead of just listed. Okay, so we're going to do that today. There's a finite. Finite is one that ends. And then there's infinite sequence, which goes on and on and on, forever and ever and ever. So A1 would be the first term, A2 is the second term, A3 is the third term, A4 is the fourth term. Usually that's the case. On occasion, they like to start the series at A0 for some reason, and A0 will then be considered the first term. And then you would just go on from there. So there's different ways of writing this. So for this one, if they want us to list the first 6 terms, they give us an actual equation or a function for an. So that would mean that the first term would be 2 times 1 plus 5. I'm just going to go ahead and do that, 2 plus 5. Then the second term would be 2 times 2 plus 5. And so everywhere there's an n, we get to replace it with whichever term you're on. So for the second term, it's going to be 4 plus 5, so that's 9. When we do the third term, it's going to be 2 times 3 plus 5, so that's 6 plus 5. You can probably see the pattern that's happening over here. And the numbers are going up by 2, which is not a coincidence because that's a 2. The reason it didn't start at 2 is because of this plus 5. So instead of starting at 2, it started at 5 numbers further or greater than 2. You can continue to plug in numbers. Once you see the pattern in the first 3, you can fill in the rest if you'd like. But this one would be 2 times 4. So that's 8 plus 5, which is 13, so on and so forth. And so if we want to do 6 terms, it would be 7, 9, 11, 13, 15, 17. If you want to double check that by plugging in the last 2 numbers for A5, the 5th term would be 10 plus 5, and then the 6th term would be 2 times 6 plus 5, which would be 12 plus 5. All right, for the next one, and if you want, you can go ahead and try the next 2 problems, or I will do them, and then you can try maybe the next 3. We can do these together. This is a different way of writing it, so they write it in function notation. So you're going to do function of the first term, second term, third term, fourth term, 5th term, and the 6th term. You'll see a pattern as you start for a second. So we're going to have -3, and then this is going to be to the 1 minus 1 power. Again, you're replacing n with this number, okay? So that's going to be -3 to the 0 power, which is 1. For the next part, we're going to have -3 to the 2 minus 1 power, which is -3 to the first, which is -3. -3 to the 3 minus 1 power, which is -3 squared, which is 9. The next one will be -3 to the third, which is -27. And you can probably see what's going on here. They're multiplying by -3 on the way down. Okay, so the numbers here would be 1, -3, 9, -27. The -27 times 3, which would be +81, and then 81 times these are -3, excuse me, that they're multiplying by, which is -243. Later on, you'll learn that this is a geometric sequence because they're multiplying by the same number over and over again. And this one would be called an arithmetic sequence, the first one, because they're adding the same number over and over. For the next one, the next one's a fraction, so we have a little less space to work these out. So once you see the first 3 terms, we can probably determine the last 3 terms based on the pattern. So I'm just going to do the first 3. And then we'll do the second or the last three, like the fourth, fifth, and sixth term by pattern. So for the first term, we're going to do 1/2 times 1 minus 3, which is 1/2 minus 3. So the 3, I'm going to change that into 6/2. And that gives you -5/2. For the second term, we're going to do 1/2 times 2 minus 3. And I'm going to leave these in halves so you can see the pattern a little bit better. Okay, so this one would be 2/2 minus 6/2. Okay, so this is 2/2. Okay, we're multiplying by 2. It's like multiplying the top number by 2 if you want. So 1 is easy. This is just 2 over 1 that you're multiplying by. So that's 2/2, which is -4/2. For the next one, you could probably figure out for the third term that it's going to be 1/2 times 3 minus 3. So this number would be 3/2. The -3 is, again, -6/2, which is -3/2. So you can see the pattern already. But when we write the answers down, we need to write those reduced. So the first number is -5/2. The second one is -4/2. We reduce that. The next one's -3/2. You cannot reduce that. The next one would be -2/2, which would be -1. After -2/2 would be -1/2. 1, 2, 3, 4, 5. And the last term would be -0/2, which would be 0. So what is happening in this pattern is that they're adding a half every single time. Notice here that they were adding 2 in the first one every time, and here they're adding a half. So when it's like in linear form, what would normally be considered your slope is actually the number that's being added every single time as you go. Go ahead and try the next ones and see what you get. Pause the video and I will go over them. All right. So for the next 3 problems, we'll go ahead and check the pattern by plugging in numbers. So for the first term, it's going to be everywhere there's an n, you're going to put a 1. So 1 over 1 plus 1, which is 1/2. For the second term, everywhere there's an n, we're going to fill that in with this number here. So we'll have 2 over 2 plus 1, which is 2/3. For the third one, we're going to have 3 over 3 plus 1, which is 3/4. So you could probably figure out the pattern. I'm going to move this down a little bit. So here we're going to have 1/2, 2/3, 3/4, 4/5, 5/6, and 6/7. So the top is n. So basically n goes 1, 2, 3, 4, 5, 6. And the bottom is 1 more than the top. So that's what that means. N plus 1 just means that the denominator is 1 more than the numerator. For the second one, A1 is 1 plus 4. A2, the second term, is 2 plus 4. The third term is 3 plus 4. So you can already see the pattern. It's just going to be 5, 6, 7, 8, 9, and 10. And just like this one, they were adding 2. This one, they're adding 1. If you have a slope, if it's in y equals mx plus b format, then whatever the slope is how much the number's going up every time. For number 3, we have the first term, which is -2 times 1 minus 1. For the second one, we have -2 times 2 minus 1. For the third term, we have -2 times 3 minus 1. And for the fourth term, you have -2 times 4 minus 1. And hopefully you can see the pattern. They're multiplying by -2. So 4, -8, positive 16, and negative 32. Okay, so writing rules, these are a little bit more difficult. You kind of have to see the pattern, see what's going on, and try to come up with an equation. They aren't always very simple. The simplest part maybe would just be to come up with the next couple of terms. So if I were doing this one and I was trying to come up with the next two terms, same thing here. See if you can do that for all of these before I give you those answers. So see if you can come up with the missing numbers. You might want to pause that and then see if you can fill those in and then come back. So for the first one, I'm not sure if you can see what numbers these are, but the next term would be -125, and the one after that would be -216. If you see those numbers, hopefully it triggers kind of an event of what you think is happening. So, and we try to do these patterns from starting with the number 1, 2, 3, 4, 5, 6, like the first term. So the first term, second term, third, fourth, fifth, and sixth, what's happening is that we're raising them to the third power. But not just raising to the third power, we also have to attach a negative sign to them. And that negative sign can be in the front or on the inside. I'm going to go ahead and, because it wouldn't make a difference. So the 1, 2, 3, 4, 5, 6, that's the n, because that's the number that keeps changing. The other numbers do not keep changing. So then this, the part that does not change, is the formula. Okay, so we put an AN in the front. The numbers 1, 2, 3, 4, 5, and 6. Those are the numbers that change if I put those in there. And then if I put in the number 1, I would get the first term, 1 to the third with a negative in front. If I put in the number 2, I would get 2 to the third with a negative in front, and so on. So if I went to the sixth term, I could put a 6 here, raise it to the third, and multiply it by -1, and that would give me the sixth term. That's how you know if your formula is right, if you can plug in any of these numbers and get to the correct term. The next one's not as easy. So you kind of have to think about this a little bit. This goes, I'm going to add 2, then I'm going to add 4, then add 6, then add 8, which means then I'm going to add 10. That's what's happening if you were just looking at what's going on. They're adding different numbers every time. Okay? Now, if we want to do it in terms of 1, 2, 3, 4, 5, and 6, if those were the numbers we were plugging in, okay, so let me see if I can line these up. So we have 1, 2, 3, 4, 5, and 6. We're trying to figure out how do we get to this number. So I can't really add anything to these. Like if I added or subtracted 1 from this, then I would have to subtract 0 from that, add something to that. So the addition isn't right, but let's try multiplication. So 1 times 0 is the first one. 2 times 1 is the second term. 3 times 2 is the third term. 4 times 3, 5 times 4, and this number is wrong. This is a 30. I don't know why I put a 10 there. And 6 times 5. So n is the red number. The bottom number, those all change also, but how are they related to n? So the bottom numbers, every time we multiply the n values, the 1, 2, 3, 4, 5, 6, they're multiplying by one number that's smaller than the top number. So that would become n minus 1. And that's the formula. So if I plug in a 1, then I have to multiply it by 1 minus 1, which is 0. Again, these are a little bit harder to do. Some of you will catch on sooner than others. There are formulas coming up later that will help you determine what those formulas are. And when it says write a rule, I should have probably mentioned this before. A rule is just a formula for the nth term. So that's just for any term, basically. Whenever they give you fractions, it's much easier to write these as, if they're fractions and whole numbers, to write them all as fractions. So 1 is 2 halves, then 3 halves, 4 halves, 5 halves. You can see that this one would be 6 halves, and this one would be 7 halves. So when you're writing this formula, the bottom number is going to be a 2 because it is always a 2. There's nothing that changes. It's a 2 for everything. The top number, remember that we said that n is 1, 2, 3, 4, 5, and 6. But these are one more than that, so we would write n plus 1 to get to these numbers. So for the first term, it's not 1. So if I put a 1 here, it would be 1 plus 1. It's 1 more than that. Okay, so this is the formula for that. For the next one, this one again is a little bit tough. So this goes up 3, 5, 7, 9. Okay, so that would be 24. And then the next one is 11, so that would be 35. And a lot of these that they go up by, like if I even this one, I could have done it this way probably. If you see that it goes up by 2 on the second one, like if you went to the second part, then you could see that the second difference is the same, and that usually means it's an n squared equation. So this one again is difficult, but it probably is something squared. So 1, 2, 3, 4, 5, and 6. So if I square each of these, that would give me 1, but then I would have to subtract 1. 2 squared is 4, and I would subtract 1. 3 squared is 9, minus 1. 4 squared is 16, minus 1 is 15. 5 squared is 25, and then 24. And then 6 squared minus 1 gives me 35. So again, the n is the 1, 2, 3, 4, 5, 6. And then we're squaring all of those. And then we're subtracting 1. And this should be a subscript here. Again, I could have done the same thing up here on this one, which is the second difference is the same. So I could have said that that's 1. Let me do the 1, 2, 3, 4, 5, and 6. And then you can square it. So this is 1. To get that, I have to subtract 1. 2 squared is 4, minus 2 is 2. 3 squared is 9. 9 minus 3. 4 squared is 16, minus 4. 5 squared is 25. 25 minus 5. And then 6 squared is 36, minus 6 is 30. So if I did this, then I'm not sure if you could see, but the 1, 2, 3, 4, 5, 6, that's n. And then we square it, and then we subtract 1, 2, 3, 4, 5, 6, which is you're subtracting n. And these two formulas are exactly the same, so there's always more than one way to do the problems. For the last part here that I'm going to show you in this section is, we're only going to do these 4 problems, is to find the sum of a series. So a series is when you add up all the terms in a sequence. So in order to do this, this sigma symbols means I would like you to, so nicely, you need to add up all of the terms in this function by first plugging in the number 4 and then plugging in every other number from 4 to 8. Okay, so that means I'm going to take 3, so I'm going to plug in 4, okay, 5, 6, 7, and 8. So this is going to be 3 plus 16, 3 plus 5 squared, 3 plus 6 squared, 3 plus 7 squared, and 3 plus 8 squared. Okay, so we're plugging in these numbers into that equation. And then we're going to figure out the sequence, and then we'll add up all those numbers. For this one, we have 3 plus 16, that's 19, 3 plus 25, that's 28, 39, 52, and 67. And then if you add all those up, you get a total of, I didn't do this ahead of time for some reason, 205. So the sum is 205 of this sequence. So go ahead and try the second example. I think we'll go ahead and stop at the next one. You try it first, pause the video, and then come back and we'll put that in. So, or I'll do the answers. So here we go. K equals 3, 4, 5, 6, 7, 8, and 9. So in this case, we're plugging in the numbers 3 through 9 into that. So 4 times 3 minus 1. 4 times 4 minus 1. I don't know, I put 1 instead of 11. 5 times 4 minus 1. And these are going up by 4, so I'm just going to go ahead and put those numbers in. 23, 27, 31, and 35. Again, if you could tell that they're going up by 4, you can go ahead and do it that way. So what's this? So we have, if I add those all together, 161. I didn't double check it, but I'm pretty sure that the answer is 161.